Thank you very much. Hopefully you can all hear me. If not, say something. Sometimes I end up talking to myself because I'm thinking of other things. But we'll try to make sure you get all the message, I guess. This is residential wind or wind turbine basics, you might say. It's not intended to be, all-inclusive of everything, but we're more than happy to get you introduced to the subject and let you know kind of what you need to know to start with. And you're welcome to ask questions along the way. I guess we've got 50 minutes to work with here, so we'll try to be somewhat brief, but at the same time somewhat thorough. We've identified a few things here to start with that we wanted to go over. Primarily, wind speeds is the first item. Well, obviously, if you don't have wind at a certain speed, then it's not worth anything. But we want to make sure that you understand wind is very site-specific. And by that, I mean it's very site-specific. It might be down to the nearest, 100 feet or sometimes even less. We've got 2 wind turbines in our office, and they're 35 feet apart. There's times when one runs and times when the other one doesn't run. And we are constantly asked the question, is something matter with the other one? No, it's just because the wind was just that much difference from one place to the other. If one got the wind gust that got started and the other one didn't, or vice versa. It makes that much difference. To show you some of the differences across the country, this is a pretty nice map that shows a huge range from the mountainous areas over in the Rockies there all the way down to the Florida area. You see there's virtually nothing down that area. We don't even think about wind basically there. That's where solar becomes more important. There's a nice corridor through the center, which is where we're at. It's even a little bit better in the northwest part of the state of Iowa. There's actually some hot spots within the state that way too that's even better yet. If we look at Iowa itself, you can see the yellow here. That's the better spots of Iowa itself. We're down in Waterloo, so it's more in the kind of the blue area there. It's one thing to have good wind. It's another thing on the consistency of the wind. Here's our turbines, for example, again, with the only 35-foot distance between the two. We have a good monitor that way. If one's a little closer to the building, if there's winds from that direction, one's is affected a little bit more from the building than the other one. You also have to be aware that if you have any other features in the area, and we'll talk about that too, that you have to watch for that.
You said Waterloo's in the blue area. What do those numbers for the blue area say?
Those numbers, it's about 15.7 to 16.8 miles per hour. That's actually a little bit higher than what you're really going to get. That's based upon the average 70 feet. I believe this is what, I don't know if it says on there. That's awful small to tell, but it's about 70-foot elevation.
Is that how high your turbines are there?
No, these are only 35 foot. So there's definitely a difference in the wind speed that you're going to get with the shorter ones. Higher is always better, and we'll talk about that too a little bit. Geography also makes a substantial difference. We talked about obstacles. If you're on top of a nice rounded hill, that's great. We say a rounded hill. We don't say a cliff. So be careful that way. And the first example here, it's just a gentle round. You're at the top of the area. You might be the top of the area for several miles. That's ideal if possible. The next best is just open flat terrain where you've got the wide open expanse. You don't have to worry about any obstacles in the way. So the wind is going to just kind of howl through there basically as much as it can. It is okay, and we call it satisfactory here, if it's somewhat open, somewhat not open. We roughly say 300 degrees and 25 feet above the nearest obstacle within 500 feet horizontal. There's no exact magic to that. That's just kind of a rule of thumb that we found over the years in using ours, that certain obstacles, that distance, start to affect it when they get certain height proportionately. Some people say 35 feet above, some say 25. 25 is for sure the minimum in that kind of a case. Obviously, if you've got obstacles very close, that's just not really, wise to do. It's kind of like putting your solar panels in the shade. Why would you do that? It's the same kind of effect. And then, but really, the worst case is extremely gusty or upwinds, for example, near a cliff or a river, something like that, where you've got good winds as far as the speed goes. You can go out there with your anemometer and you might have 30-mile-an-hour winds that day, but you got to look at the direction of the winds. If the winds are coming up at 45 degrees to that turbine, it's going to rip it to shreds. You're not going to end up with anything in the long term. So you might produce power really good for a while, but in the long term, it's not good for the turbine. We talked a little bit about turbine height. We'll start with the extreme here. This is, as you can see, very, very tall turbine. It's somewhere around 400 feet tall. And that's a full-grown tree down there. So it makes the tree look like a toy almost, like a model. And so therefore we say, yeah, higher is better, and you get more wind that way. But in reality, there's always a trade-off. And so what you've got to do is allow for the higher cost once you go higher. There's a cost factor there. If you get an extra 2 or 3 miles per hour, that's great. It's much better performance. You get more consistent winds, but now you've upped the cost of your turbine, obviously. It works the same for residential. It's amazing the differences. People come to us sometimes and say, well, we've got a beautiful site, we get wind all the time. Then we go and look at it, and it's surrounded by a grove of trees on 3 sides. Well, it's windy all the time, but you don't have good wind. There's a big difference between good wind and windy. You need the consistency, you need the clean wind as much as possible. So you also have to be aware that higher may become an aesthetic problem, even for your residents. Your neighbors might not like it if you go higher. You go 100 feet tall, something like that, they might say, God, I had a nice view before, now I'm looking at their turbine. If you're both sharing power, they might like that. There's some people that have come to us and thought about doing that, where they'll go in and kind of community-based, you might say, and share a turbine. Once you get into that level, that's a whole different situation politically and friend-wise, you might say, because if you use more power than he does that day, are you going to pay more of the share of that cost that day, or what's going on? Somebody's got to have a balance there. And so it also costs more to maintain, whether you're residential or again, commercial. It doesn't make that much difference. If you're 35 feet up, you can reach it with a cherry picker. If you're 75 feet up, you can reach it with a cherry picker. If you're 100 feet up, that's another question. And there's tilt-down towers. There's monopoles. Like I said, I picked the tallest one here so you can get an example of how high you can go. And you can do the same height with a residential-sized turbine. The height isn't the problem. It's what you do to support it and how you get to it to maintain it. The tilt-downs sound great, but the problem with the tilt-downs is that you're relying on those cables to be perfect all the time when you put it back up each time. So somebody's got to check the tension and all that every time, too, if you go that route.
Can you go back for just a minute on the height and speak to your experience with city and county governments with codes and restrictions on height of towers?
Sure. Some cities have codes, some cities don't. Ours, for example, has no height limitation. We're from Mason City. However, they do limit how far from the property line you have to be. So, for example, for easy calculations for round numbers, if you have a 100-foot tall turbine, you've got to be 110 feet away from the nearest property line. It's a 110% rule. That doesn't sound too bad, except that how many people have a lot that's 250 feet wide, okay, in all dimensions. Plus, you don't normally want to put it dead center if you can help it either. You want to get it to the back or something like that, so your lot has to be even bigger that way. If you get shorter, then all of a sudden your trees become obstacles, just like the other examples. If you live in the farm, that's probably not so bad then. You can do it. But the ordinances are starting to change. There was a lot that had wind ordinances that were concerned about noise. Noise with most of the turbines, and I think we talk about that here later too, is not such an obstacle for that anymore for some of them. But as far as location on the site, check with your city first that it's that you can do it in your location, that there's no special requirements. Oftentimes you will have to have a variance put out there, in which case you'll fill out a paperwork and take it around to all your neighbors, and they have to sign off that it's okay with them. We even had one case where the city required 3D perspectives of how it will look once the turbine's up there. Well, you know, that's all possible. It's not hard to do, but somebody's got to take the time and spend the money to do it. And sometimes that's a killer, you know. I mean, if you're spending another couple $1,000s just to get some pretty pictures, then, you know, that's another item. They've since kind of decided not to do that. Most people know what they look like. You can tell them the location, and then they can judge accordingly. To answer that?
Thank you.
Sure. As far as size matters. This is an example of some swept area and rotor diameters for the smaller turbines. The Berge XL1, which is a 1K or 1,000 watt turbine, you see the size of the diameter of the turbine itself is right there. If we go up to African wind power, that's the 3.6. It's almost 50% larger, the swept area, the area that captures the wind. Swept area is very important. The formula that calculates the power is related to the wind speed. It's the cube of the wind speed as well as the swept area. That all makes a difference on what power you're going to get. So both of those, for example, the African and the Berge are 1,000 watt turbines. But because the African has bigger swept area, it runs at lower wind speeds and produces more power. So in effect, you're getting more out of that 1,000 watts. It typically produces about 20% more than the same wattage Berge does because of that. And you'll see different ones there, bigger size too. The Jacobs is another one there. Be careful on some of that for maintenance. We'll talk a little bit more about that too later. It also makes a difference on the shape of the blades. The Berge has pultruded blades, but they're flat. They're kind of like a 1x6, you might say. So they're really strong, and that's the way they advertise them as being really strong. And they're right, they are, but they're not aerodynamic. It's no better than putting up a 1x6 basically for the blade. And to make the point, here's the AREs, which is abundant renewable energy ones. They've been wind tested at the NREL test site in Colorado, and they found that the change in the blades, you know, improves the performance about 20%. So it's much better performing because of just the change in the shape of the blades. And eventually there'll be even more improvements yet too. That's just the nature of that. There are some limits. Some of the larger commercial, just as a comparison, they think they can change the shape of the blades and pick up another 20%, even more than the 20% they picked up to this level. So we'll see how that goes. As far as the turbine types, we're used to seeing the horizontal axis. You probably haven't seen one of those before, though. That's where somebody had the idea, well, if one's good, 6 is better, right? Or 7, however many is there, I haven't counted them. But what happens is then you've got the after effects. You've got the wash effects from one affecting the next one, affecting the next one, affecting the next one. Plus, remember how we said that wind is very site-specific? What happens in this level is probably not, and I'll try to use the pointer here since I can't reach that high. From that turbine to that turbine, the wind may have changed direction just 2 or 3 degrees. Well, in that 2 or 3 degrees, you know, you've lost some performance as well. Well, then you go another turbine down the row, and you lose another 2 or 3 degrees, another 5 degrees or 10 degrees, and by the time you're at the end, the wind might be going, you know, 25% the other direction. So the whole system just doesn't work. Okay, but you'll see stuff like that out there. You know, this kind of gadgety type stuff. So be careful when you talk to different people. This is just a large two-bladed one. You'll see some two-bladed ones, and I should have put a Southwest Wind Power two-bladed